Okay, 3CB is we are trying to find the shortest distance that we can meet with and stay within a parameter. So the scenario given here is you're working for a power substation, and we're trying to figure out just how far can we truly extend OP up without hitting the wires. So that's our scenario. So these are the steps that we go through to find that. So step one is, of course, tape it down. So I'm still going to get those nice lovely little vertical lines to line everything up with. And you can't see this, dang it. Come on, try to get it in there where you can see. There we go, that's better. Okay, so we got that lined up, right? And tape it in place. Trust me, it makes a difference in a little while. Right now, I'm just going to go ahead and do it because it's just easier to go ahead and do them all at once. Okay, so I'm just connecting those first real quick. All right, so we're going to use the architect skill when we get to this in a minute. So our next step is we want to get to this. To get to it, sorry, one second. We need to connect a B here in the H view. So this is horizontal and frontal. So we need to connect this to here. So we're going to do our A and B and connect those there. So we're going to take that connected line, and now we're going to use this as our parallel line. And this is what we're going to draw a parallel line through 1, 2 to the AB. Because we're trying to find that true length of AB. So here we go. So that now becomes our line. So see, it's lined up to there. So I've lined it up. Pull it up till I get that parallel line right there. Okay? And then from that parallel line, I'm going to draw my perpendicular lines. And I actually need to pull that up to here because I need to get that point here. I need to bring that line up perpendicular. So those are each 90 degrees because they're nice perpendicular lines. Okay, so I've drawn those lines up. And I'm going to try to find actually where OP now lines over here. So I'm going to find the true length, and then I'm going to find out where the OP finds this distance that OP for that tire lies out here in this space. So again, we got to transfer and do some basic little measurements, right? So we need to find a distance. So we need to find the distance A and B. Little a, little b. And then we're going to transfer that. So from the top of that little transformer tire, I guess is the best way to describe it, and mark. That's distance A. Point B. Dang it, it's moving on me. That's distance B. And that's going to become our true length of line AB. And that becomes the true length line of AB. All right, so next we're going to follow this line up here, and we're going to find out where is actually O and P on this line. So to do that again, we've got to know, we got to find a couple of different measurements. So what we're going to actually find is we're going to find the measurement from the height here, sorry, to here, little c. And then we want to find the height from here to here, little d. Oops, excuse me. And then we're going to transfer that c and that d along this line here. So here's c. So there's your c, right? And then we find our d on that same exact one and mark it. Because from there to there is your d. And so those 2 points, that's your O, and that's your P. So that's where OP is now. Now our next step is we want to get, sorry, get my brain going here. We still have to finish getting it. We're still not quite there. We need to find out where does it meet over here and just how far up can I reach it and make it go. So move my tape, move it around. The next is we're going to have this line is going to continue out. Because what we're going to do is we're going to have a perpendicular line to it running through line 2. So bring it down a little bit. I'm going to go ahead and just lightly draw it out a little bit more, make it a little easier for me here in just a second. Okay, so I brought that out. Going to line it up with it now. Bring it up. Okay, so I now have that perpendicular. That means this corner and this corner. That's your 90. They're connected together. All right, so the next thing I need is I need to find a couple things. I need to find on this line right here, where is the center point for the arc, for the radius, for the height of it. So to do that, I'm going to have to find little g. Okay, so where do I find little g? Oh, before I do that, hang on. I'm going to go ahead and parallel those up because I'm fixing to move this, untape it, and move it around. Okay, I'm going to remove the tape so I can move it around so I can help you find those other little measurements. Okay, so we're going to find measurement G. Measurement G is this measurement from here to here. So that's our little g. So we find little g. We pull little g up on this line from where it meets here and mark. That's our little g. And what that is that gives you your center. The center mark for the radius here of h. Now if I look here, it says that the clearance is 2 foot. So it needs to have a 2 foot clearance. And I'm going to take my architect scale, 1/4 inch equals to foot. I'm going to take my compass if I can find it, and I'm going to mark 2 foot on it. I'm hoping you can see this. So I find that 2 foot mark. See how it's here and here? So that's my 2 foot mark. Place that on the center point that I just found. And oops, dang it, without letting it move. Gosh darn you. Draw that arc. Now why is that important? Because that's our maximum area. We need to find out where OP comes through and hits here so that we can find out just how tall can we get this tower, this OP, to go without hitting it and without causing anybody to get electrocuted, essentially. All right, so let's find our next measurement. So we need to find little I. Little I is the distance from here to here. And we want that to come on this line here, and that's going to be at both P and O because they line together. So there's my I. Oh, no, almost forgot. Hello, that would be bad. I need to continue that line out to here so you could actually do it. So you know how to bring it out. Make sure I have it switched and moved I, because sometimes you do when you move things. So there's your distance I. So that's going to be my PO. And then if I follow the PO through, it'll hit here and it'll tell me how far I can actually go without messing it up. So now I have my P and I have the O. Here's the maximum distance right here. This distance from here to here is the maximum distance you can go before it hits that 2-foot radius. Does that make sense? Because that's where that radius comes around to here. So here, see how that comes through? That's where it hits. So that's as max you can go before it starts hitting. So you would measure the distance from here to here, and that's going to give you your max distance. And again, make sure you're using your 1/4 inch scale and the architect scale when you do this. So you lay the architect scale in here and you measure it and find out however many inches that might be. And let's just, for an example, you know, you take it and make sure you're lining it up again. See, it's not 2, so it's going to be 1 foot something. So you find the 1 foot mark here, and then you have to figure out how many inches, and that's your max clearance you have. Whatever that distance is from here to there, that's your max. And you take your scale and you lay it on there, and that's going to tell you what is the maximum distance that you can put in the tower or extended tower, whatever you need to do, without hitting one of these wires and electrocuting yourself or somebody else.